You might have heard that this is the year of AI agents, but some prominent voices in the AI community, such as OpenAI co-founder Andre Karpathy, they paint a bit of a different picture. They're actually saying that this is the decade of AI agents, and that today's AI agents, they kind of struggle with some basic tasks. They're being a bit oversold, and it will take advancements over the next 10 years to work through all the issues. Now, why do today's AI agents struggle with many tasks? Well, there's a lot of reasons. One of them is they just don't have enough intelligence, the model behind them. They also struggle with computer use, interacting with a computer UI, and they lack continual learning, and they lack some multimodal capabilities. So whether this is the year or the decade of the AI agent, let's examine 3 use cases for agentic AI. So the first one we're going to look at, number 1 here, that one is going to be where AI agents are already providing tremendous day-to-day utility. They work really well. Number 2, use case number 2, that's considered a common use case. It comes up pretty much every time a new agentic AI model is released, but as you'll see, it kind of falls a little bit short in practice today. And then finally, number 3 is going to be an aspirational use case that's a little bit beyond current capabilities, but may be far more commonplace a decade from now. And use case number 1 is coding assistants, AI agents that work together alongside developers, and they can do a bunch of stuff, like they can write code, they can fix bugs, they can generate documentation, they can review pull requests, those sort of activities. And of course, this isn't hypothetical. If you're writing code today, chances are you're already taking advantage of agentic coding assistants to help you. So, question is, why are coding assistants such a good fit for the agentic capabilities of AI models today? Well, let's go back to those 4 AI agent capabilities I've mentioned: intelligence, computer use, multimodal, and continual learning. So let's first of all start with the capability of intelligence. Now, code has a number of things going for it. It has a really good structure. Code is very structural. It has a lot of well-defined rules. So the agent doesn't really need human-level reasoning for most coding tasks. It needs pattern matching across millions of code examples. And current models are really good at this sort of thing. And it doesn't hurt that programming problems, they tend to have clear right and wrong answers. The code either compiles and it passes tests, or, well, it doesn't. So that's that one. What about computer use? Well, it's barely needed because these agents, they work within integrated development environments, IDEs. And those are well-defined interfaces that haven't really changed dramatically in years. And agents don't have to navigate inconsistent web UIs or click through enterprise applications. All right. What about multimodal capabilities? Well, not really required. That's because when it comes to code, it's basically text in and then text out from the model. So code, comments, error messages, it's all text-based and it's highly structured. And then as for continual learning, well, yes, programming languages and frameworks evolve, they change, but somewhat slowly and usually with pretty extensive documentation. So an agent using a large language model, that would already have been pre-trained on a lot of that information. It was part of its training set. So it has knowledge already of vast amounts of source code and knowledge that applies broadly across most projects. So coding assistants, they play to the strengths of current AI models. They operate in structured environments, they have immediate feedback loops, and they work with well-defined problems. Okay, now use case 2 is travel booking, and this is the one that comes up in practically every demo of new agentic AI models. And the basic premise is a series of AI agents that handle like booking your entire trip. So that might involve booking some flights across airlines, and then maybe comparing some hotel options, and then booking everything, making sure that we get the optimal prices, and then ultimately kind of managing your calendar. And yeah, this does seem like a perfect fit. It's a defined task with clear goals. Get a person from point A to point B at a reasonable cost. So why does this only somewhat work today? Well, if you have what we can call kind of simple, happy path scenarios, well, it does kind of work quite well. So if you need to book a direct flight and find a standard hotel room, current agents, they can handle that decision making. The information they're working with it's mostly text-based, it's flight times, it's prices, it's hotel descriptions, and that's within their capabilities. But it doesn't take long to run into limitations. So let's go back to those 4 capabilities, and we're going to start again with intelligence. And the big thing with intelligence is that when it comes to that, edge cases, they kind of kill it. What happens when a flight gets delayed, or if you're connecting through a city with certain visa requirements, or you're traveling with an infant? Well, current agents, they really don't handle the long tail of real world complications that human travel agents do. And if you've ever traveled anywhere, then you don't need me to tell you that travel is full of edge cases. Okay, computer use is another big one. Every airline, every hotel chain, every booking site, they all have different UIs. There's a lot of UI variants. They also might have captures, and they might have authentication flows. And in fact, many of them are intentionally made difficult to automate. So when agents need to navigate the actual websites instead of using APIs, that is where they can struggle a bit. Okay, what about multimodal? Well, reading flight times and prices from text is fine, but there are some nuances. Like take, for example, if we have a hotel map that we actually need to read to see if that hotel is actually walkable to your conference center, or if it's just kind of technically nearby. Trust me, that's one I've struggled with a few times. Well, that does require multimodal understanding that current agents, they might struggle a little bit with. And then what about the continual learning aspect? Well, when it comes to continual learning, your preferences, they really matter. Now, sure, you could fill out a profile. You could say you prefer aisle seats and Marriott hotels, but the real challenge here isn't just filling out the profile, it's actually learning. So we need to learn by observing the world and then getting feedback on those observations, and it is really a loop. The agent needs to figure out that, let's say you're willing to pay more for direct flights on Monday mornings, but you like to take connections on Friday afternoons. These are patterns it needs to learn from your behavior over time, rather than just the simple preferences that you can think to list up front. So travel booking, it works well enough to be impressive in agentic demos with cherry-picked scenarios, but today is probably not reliable enough that you would fully trust it with your actual travel, at least without close supervision. All right, it's time for use case number 3. This is my aspirational one. It's automated IT support. So this is a bit more than an agent that helps answer help desk tickets with canned responses. That's kind of level 1 stuff. And well, I would say that does already work today, but I'm thinking more about an agent that does a bit more than that. So it actually completely autonomously logs into a user's machine, then it diagnoses whatever the problem is, and then it actually has full control to go and fix that problem autonomously. Now, this seems like the perfect use case for AI agents. It's repetitive, it often follows patterns, but would you trust an autonomous AI agent with free reign on your laptop to install fixes and delete applications without your consent? Yeah, probably not. So why not? Well, let's take a look at the capabilities again. So what about intelligence in this case? Well, every user's setup is kind of unique to them. So there are a lot of different paths we could take here. I think we could say most machines have a bit of a quirky, unique setup. Now, a simple Outlook issue on one machine, that might be a corrupted file. On another, it might be a proxy setting, and then it could be an expired certificate on a third. And current agents, they often can't handle these kind of endless edge cases. Now, there are also significant issues when it comes to computer use. There is a lot of requirements here. So the agent, it needs to be able to navigate a lot of stuff. So what does it have to navigate? It has to navigate that user's machine. And well, people have different machines. So, just for one example, if you're a Windows user, it will need to be able to navigate Windows settings, or if you're on a Mac, it would need to understand Mac preferences. And that's just the operating system. There's also the application UIs, which are all specific to those applications and so forth. And all of this, remember, is potentially running on a system that is in production. Today's computer use capabilities, they just aren't reliable enough for that level of trust. Okay, what about multimodal capabilities? Well, users, they're going to send things like screenshots in. They might speak to the agents, so you're going to have some kind of verbal stuff as well. And that verbal description might not be that instructive. It might be saying things like, it's doing that thing again, and you've got to kind of figure out what it is. The agent needs to piece together whatever users can capture in the moment. And then when it comes down to continual learning, the agent needs to learn specifically from outcomes. And those outcomes will adjust over time. So when software updates break things, which fixes are actually going to work in your specific environment? As new devices get added and new issues emerge, the agent needs to adapt based on what's working and what's not in practice. It needs to learn from the feedback loop of thousands of support interactions beyond a model's initial training data. So basically, this use case is still emerging, but it's just not fully there yet. So year or decade? Well, actually both. We're in the year of AI agents for narrow, well-defined tasks in structured environments, but we're in the decade of AI agents for the broader vision. Agents that handle messy, real-world problems with reliable computer use, with intelligence about edge cases, with true multimodal understanding, and learning that adapts to your specific environment. So for now, you've got a coding task. Well, an agentic assistant might be just what you need. But if an AI agent offers to fix your laptop autonomously with today's models, well, maybe at least ask it to show its work first.